There are two logarithmic functions that come up more often in real life than all of the rest. So they kind of get their own names and their own notation, and we just want to take a look at those specifically. The first one is a logarithm with base e. We mentioned that e is a number, 2.718, some other stuff. And we called e the base of the natural exponential function. So its inverse is hopefully logically going to be the natural logarithmic function. Technically, this is y equals log base e of x. But we're not going to write it that way. The way we're going to write it and the way you'll see it written is y equals ln x. And when you see this ln, think log base e. I also want to mention this is a lowercase l. It is not a capital I. It's hard to tell a lowercase l from a capital I sometimes, but we're talking L as in logarithm. So this is ln x. Was named by somebody, I believe, who was French. In French, you put the adjective after the noun, so logarithm natural, however you say that in French. So ln x is the natural logarithmic function, which is the log base e of x. It works just like any other logarithmic function. We can evaluate it. If I say, let's evaluate the natural log of e squared, what I'm really saying is the base is e. What exponent do I have to put on e in order to get e squared? At which point it becomes sort of one of those self-answering questions. The exponent I have to put on e in order to get e squared is a 2. If I say the natural log of the square root of e, we're going to remember that we can rewrite roots as fractional powers. And again, what exponent do I have to put on e to get e to the 1/2? And that'll just be 1/2. So we can evaluate natural logarithmic functions. You can do them on the calculator too. Most calculators have a natural log and natural exponential key on them. Scientific calculators do. As far as a graph, e is a number. It's something between 2 and 3. E to the 0 power is 1. So log base e of 1 is 0. It's going to go up a little slower than log base 2 of x and a little faster than log base 3 of x, since e is a number between 2 and 3, something like that. And I get the vertical asymptote to the left. There's my graph. So it's just like every other logarithmic function, it just happens to have a base of e. The other one that comes up a lot is log base 10. And that's because we work in a decimal system that's base 10. So it's sort of expected that a log base 10 is something that we would see. This gets its own name too. This is a common logarithm. Technically, it's log base 10 of x. But again, like the natural log, you won't see it written that way. It's common, after all. I'm just going to write log, L-O-G, of x with no base specified. So if you see y equals log x with no base down here, it doesn't mean you don't know what the base is. It means you know the base is 10. This is a common logarithm. So y equals log x means y equals log base 10 of x. And you can evaluate, as with any other logarithmic function. I can say, if I want to know what's the log, common log of, say, 10,000, 10 to what power gives me 10,000? Count the zeros. 10 to the fourth power is 10,000. If I want the log, common log of, say, 0.001, I'm going to recognize that's the thousandths place, so this is really log of 1/1000th. Well, 10 to the third power is 1,000. To get it into the denominator, I'll make the exponent negative, and I get a power of -3. The graph is not any different from any other logarithmic function. When the base is larger, when I go up to the right, I'm going to go up slower because it takes longer to get all the way out to 10. My next point is 10, 1. So it's going to go up still, generally the same shape as any other logarithmic graph, just goes up to the right more slowly. And those are our two frequently seen bases, base e, the natural logarithm, and base 10, the common logarithm.